All right, let's dive into one of the most intricate, most beautifully coordinated processes in the human body, the female reproductive cycle. We're going to think of it as a monthly symphony, a masterpiece of biological signals all working in perfect harmony. So, that brings us to the big question for this whole explainer, right? How in the world does the body conduct this incredibly complex symphony with such perfect timing, month after month? Well, to figure that out, we have to start with the body's internal clocks. To really get a handle on that timing, we've got to zoom out a bit and look at the body's internal clocks. These are the biological rhythms that set the pace for pretty much everything we do. Our bodies are kind of running on multiple timers all at once. We've got ultradian rhythms, which are super short, less than a day, like the quick pulses of hormones. Then there's the one you've probably heard of, circadian rhythms, our classic 24-hour sleep-wake cycle. And then we have infradian rhythms. These are cycles that last longer than 24 hours. And the menstrual cycle, it's the perfect example of this long-form biological rhythm. Okay, so if the cycle is a symphony, who's waving the baton? Who's the conductor? Well, the command center is actually located right up in the brain, sending out all the signals that direct the entire performance. So take a look at this. These are the main players in our orchestra. It's called the hypothalamic pituitary gonadal axis, or just the HPG axis for short. Think of it as the top-down communication line. It starts in the brain with the hypothalamus and the pituitary gland, and that signal travels all the way down to the gonads, in this case, the ovaries. Let's break down this chain of command. First, the hypothalamus kicks things off by releasing a hormone called GnRH. That's the signal for the pituitary to release its two key hormones, FSH and LH. Those two then travel down to the ovaries and tell them to start producing estrogen and progesterone. And then, and this is the cool part, those hormones from the ovaries send messages all the way back up to the brain to say, hey, adjust your signals. It's this constant flowing conversation.
And that whole conversation is all about feedback. You've got positive feedback, which is basically the gas pedal. High estrogen, for example, screams at the brain, go, 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 release a huge surge of LH. But you've also got negative feedback, which is the brake pedal. High progesterone tells the brain, okay, easy does it, let's pause, we don't need any more stimulation right now. That's how the whole system keeps itself perfectly in check.
So, now let's see how this all actually plays out in the cycle itself. We're going to start with Act 1, the follicular phase. This is all about getting ready for the main event. Now, to really set the stage, you got to appreciate this number. At the start of puberty, the ovaries are holding a massive reserve of potential eggs, called follicles. And the number is just astonishing. Some are between 300,000 and 400,000. But believe it or not, that's just the starting point. Because out of that huge pool, that ocean of hundreds of thousands of follicles, only about 400 to 500 will ever fully mature and actually be released during a person's entire reproductive life. The selection process is unbelievably picky. And this really drives that point home. It means that over 99% of all the follicles a person starts with are naturally eliminated. It's a process called atresia. They never even get a chance to reach ovulation. It's just a staggering level of attrition. This slide here shows us what that journey, which is called folliculogenesis, actually looks like. A small group of these tiny resting follicles gets the signal to wake up and start growing. They go through a bunch of stages, getting bigger and more complex, until one of them becomes this big, mature follicle, all ready for the next step. So what is that signal? What's the wake-up call? Well, it's a hormone we've already met, follicle-stimulating hormone, or FSH. I mean, the name really says it all, right? It is the follicle-growing hormone, and it's sent from the pituitary to kick this whole maturation process off every single month. And right here, you can see this perfect cause and effect relationship. As those follicles get bigger and mature, they start pumping out their own hormone, estrogen. And as you can see those estrogen levels rising on the left, it's sending a critical signal to the uterus, telling its lining, the endometrium, to start rebuilding and thickening up after menstruation. All of this prep work, all of this building, it's all been leading up to this one dramatic moment, the cycle's climax. The main event that the entire first half has been building towards, ovulation. So what's the trigger? What's the final signal? Well, it goes right back to that positive feedback loop we talked about, the gas pedal. Those high levels of estrogen, specifically E2, are what induce a massive surge of luteinizing hormone, or LH, right around the middle of the cycle. And wow, you can see it so clearly on this chart. Look at that incredible peak. That is the LH surge. It's this huge but very short-lived blast of LH from the pituitary. And that is the final undeniable signal, telling that one most mature follicle, it's go time. Rupture and release your egg. By this point, that one single dominant follicle has swelled up to be about 15 to 25 millimeters wide. And then bam! Under the immense pressure of that LH surge, it breaks open, and the egg is released, beginning its journey into the fallopian tube. But hold on, the symphony is not over yet. After the egg is released, we move into Act 2, the luteal phase. You can think of this as the waiting game, where the body now carefully prepares for a potential pregnancy. So, you might be wondering, what happens to the follicle that just ruptured? It doesn't just disappear. It totally transforms itself into a new structure called the corpus luteum, which is just Latin for yellow body. And this thing becomes a temporary but super powerful gland, and its main job is to run the entire second half of the cycle. Now, the corpus luteum's superstar hormone is progesterone, and progesterone is a multitasking pro. It tells the brain to hit pause so no new follicles start developing. It also signals the uterine lining to get even thicker, more stable, and more nutrient-rich. Basically, it gets the whole system ready and waiting for a potential pregnancy. And we can see that connection so clearly right here. On the left, progesterone takes over and becomes the dominant hormone. And its effect? You can see it on the right. It maintains that thick, lush uterine lining, turning it into what's called a secretory endometrium. A stable, welcoming, nutrient-rich environment, perfectly prepared for a fertilized egg. But if a pregnancy doesn't happen within about 10 to 14 days, the corpus luteum knows its job is done and it begins to degenerate. Without it, the levels of progesterone and estrogen just plummet. And that sudden drop in hormones is the final cue. The uterine lining breaks down, it sheds, and menstruation begins. And just like that, the stage is cleared and the symphony gets ready to start all over again. When you step back and look at the whole thing, from the brain's rhythmic pulses to the ovary's careful selection process, to the uterus responding perfectly on cue, this entire hormonal symphony resets and repeats with just incredible precision.